In this video, I am going to talk about expected value. And expected value, ooh, this is supposed to be an E. Expected value is really the mean value or the average value for a probability distribution. Mean value of a probability distribution. And this is really kind of like a weighted average. And the way we calculate this is you multiply each outcome by its probability. Each outcome by its probability. And then you add all of those products together. And a lot of times we talk about expected value in games of chance or when money is involved. So in a game of chance, your outcome is really your net gain, what you gain from playing the game or lose. So the outcome is the money that you profit, your gain or your loss. And this is calculated by subtracting the prize, the value of your prize or winnings, minus, and I'm going to say winnings slash prize, minus the cost to play, because you're losing that money. All right, we're going to look at some examples here. So example number 1. 150 raffle tickets are sold for $20 each. The 4 prizes are $300, $150, and two $50 prizes. Find the expected value per raffle ticket. All right, so X here, that's our outcome, and that is really the money that you earn for your raffle ticket. So money earned from the raffle ticket or your outcome. And there are 4 outcomes, right, that produce prizes. So you could win $300, right? But the cost of the ticket is $20. So 300 minus $20 is a $280 gain. Now, the probability of gaining $280, there's a 1 in 150 chance because there are 150 raffle tickets. The probability of this $280 profit is 1 in 150. All right, next prize you could win. You could win $150, but $20 you already spent on the ticket. So if we subtract 150 minus 120 is a $130 gain. So the probability that we profit this $130, there's only 1 ticket out of the 150 total that's going to win $130. All right. Now we have 2 tickets that could win $50. Right? So they're going to win 50, but they paid 20. So this is a $30 gain. Now the probability that you gain $30, that your outcome is $30, there are 2 out of the 150 total tickets. I'm not even going to worry about simplifying my fractions right now. Now, the last outcome here is that you win nothing, right? You win $0 and you paid 20. So this is really $20 you have lost. It's a negative $20 you've gained, which is really a loss. So the profit, or sorry, the probability, sorry, that you lose $20, essentially that you win nothing, or losing $20, there are 4 raffle tickets that will win prizes, which means 146 tickets that aren't going to win anything out of the 150. So to calculate the expected value of one ticket, I'm going to essentially find the average of all of these probabilities. So I am going to multiply each outcome by its probability. So we could win $280, and there is a 1 in 150 chance that that happens. That is going to get added on to the product. You could win $130. There is a 1 in 150 chance of that. Next, we're going to add on that you could win $30, and there is a 2 in 150 chance of winning that. And then lastly, there's a 146 in 150 chance that you're going to lose $20. So plus negative 20 times this probability of 146 times 150. And if you use a calculator to help you produce this value, you can absolutely type this into your Desmos calculator or to a handheld calculator, and find the expected value. And the expected value is actually negative. I'm just going to write the value, negative $16.33 repeating. So we could just round it to about $16.33, and it's negative. So you're really expected to lose money by participating in this raffle. All right. Number 2. The table summarizes the distribution of dogs in a household. Using the expected value, how many dogs would you expect to find in 120 randomly selected households? All right. So as I look at this, I see the dogs, the number of dogs, that's like our X, the outcome, what's the number of dogs in a household, and then the probability of that outcome, 0 dogs, 1 dog, 2 dogs, 3 dogs, 4. And since this is a probability distribution, all of these values must add up to 1, right? All together. All right, so let's find the expected number of dogs. Number of dogs per house. Essentially the expected value for this probability distribution. So this is really E, the expected value of X. That's how we write expected value. And now I'm going to take each outcome and multiply it by its probability. So the probability of a house having 0 dogs is 0.34. I'm going to add that to the product. Let's see, the probability of having 1 dog is 0.24. The probability of having 2 dogs is 0.21. The probability of having 3 dogs is 0.13. And lastly, the probability of having 4 dogs, what color? Let's do red. 4 dogs is 0.08. So to find the expected value, I am essentially going to multiply each outcome by its probability and add all of those products together. And the expected value, or the expected number of dogs per house, when you calculate this, is 1.37 dogs, which doesn't really make sense, but I'm going to keep it as that decimal because now I want to use this value to determine how many dogs would I expect to find in 120 randomly selected households. So this is 1.37 dogs per house. Let's take this and multiply it times 120 households. And 1.37 times 120 is 164.4, which if I had rounded this value, that would have been a different number. So now this I will round to approximately 164 dogs in the 120 houses. Please let me know what questions you have on expected value, and I look forward to seeing you soon.